All right, so here's a problem where we're asked to calculate the percent yield of a reaction. So in any chemical reaction, things don't always react completely. Sometimes it's difficult to collect all the final product, but it's very rare that you get 100% of what you expect. So in this case, we have reacted 24 grams of oxygen, and at the end of the day, we ended up with 25 grams of water. So the question is, what is the percent yield? What percentage did we get of what we were expecting to get? So at the moment, we really have no idea. 24 grams of oxygen reacts, 25 grams of water is made. Great. Well, is that good or bad? In order to figure that out, we first have to figure out what should we expect to get if 24 grams of oxygen react. So right now, this is essentially a stoichiometry problem. I have 24 grams of oxygen. I need to figure out how many grams of water I should get from that. So I'm going to set this up as a stoich problem. Remember the way we do this. We need to find the relationship between oxygen and water. So the relationship is that 1 mole of oxygen can make 2 moles of water. Next, that's going to get us from moles to moles, but we need to be able to get from grams to moles in each case. So we're going to need to know 1 mole of oxygen, what is the mass of 1 mole of oxygen? So I'm going to have to use my periodic table. 1 mole of O2. I look up the mass of O, and it's 16 once it's rounded. So O2 has a mass of 32 grams. So 1 mole of O2 is 32 grams of O2. All right, I'm also going to need to know the molar mass of H2O. So 1 mole of H2O has a mass, I add it all up, of 18 grams of H2O. So this is a good review for stoichiometry if it's been a while for that. So, all right, I have 24 grams of O2. And the first thing I'm going to do is convert that to moles of O2. So I'm going to look here, and I'm going to end up using this one here, this exchange rate. And since I'm in grams of O2, I need to put grams of O2 on the bottom. So 32 grams of O2 on the bottom, 1 mole of O2 on top. All right, so that gets me the moles of O2. Now I need to get from moles of O2 to moles of water. So that's this connection here. 1 mole of O2 is 2 moles of water. So if I'm in moles of O2 right now at the top, I need to put 1 mole of O2 on the bottom, 2 moles of H2O on the top. Okay. And my last step is getting from moles of water to grams of water, so we use this. So I'll have 1 mole of H2O on the bottom, and 18 grams of H2O on the top. So this is going to tell me how much water I would expect to get. So 24 times 2 times 18. Up top, I have 864. Down bottom, 32 times 1 times 1 is 32. So when I divide those, I get 27. So when 24 grams of O2 react, I expect to get, let's just say water here. I expect to get 27 grams of water. That's if everything goes perfectly. However, the problem says I ended up with 25 grams of water. So I got a little bit less than what I was expecting. So this should be a pretty high percent yield. So to calculate the percent yield, you always take just what you got, your actual amount, divided by your theoretical amount. And then if you want to make it a percentage, you multiply by 100. So I actually got 25 grams out of 27 expected. To make it a percentage, I multiply by 100. So 25 divided by 27 times 100 is about 92.6%. This is a pretty high percent yield. It's pretty good. I should never get over 100% yield. If you do, there's probably some sort of contaminant in your product. Maybe it still has water in it or something, but it's really impossible to get over 100% yield unless you're in a lab situation where you're measuring something wrong. So anyway, 92.6% is my final percent yield. So again, you have to first figure out your theoretical amount, usually with a stoichiometry problem, and then compare that to your actual amount to get the percent yield. So until next time, I am Derek Genova. Have a delightful day.